The amount of space inside a 3D object is called the volume. Now that space inside a 3D object could be empty, ready to be filled with something, for example with an empty cardboard box, say. Or it could be that that volume is filled with something. We could fill that empty cardboard box with air, or with water, feathers, lead, anything we want to fill it with, we could fill it with. So that volume is not just the amount of empty space inside something, it could be the amount of full space. It is the amount of space inside an object which could be empty or full. It is also possible that that volume isn't a space that could be filled, it's a space that's already been filled. If we consider, say, a block of a particular material, that will still have a volume as a 3D object. It's just that the volume is the material. It's the amount of material that is there. And it's already been filled by very nature of it being the material that it is. Now, separate to that idea of volume, depending on the material that we have, or depending on the material that we fill the object with, that object will have a different weight. And that weight will be different depending on what material we have, or depending on what we put inside that 3D object. If, for example, we were to put feathers inside it, it would obviously be much less heavy than putting lead inside it, because the lead is much heavier than the feathers. Similarly, if this was a block made out of lead, that would be much heavier than a block made out of, say, wood, because lead as a material is heavier than wood. So two blocks of the same size, the lead one will be much heavier than the wood one. If they were the same size, they would have the same volume, but obviously their weights will be different. So when we're talking about weights, we're talking about things measured in, for example, grams, kilograms, those kind of units that we talked about. Now actually, I'm being a little bit incorrect talking about weight, because this that we're talking about, the weight of something, in terms of grams and kilograms, that's the wrong word. Really, I should be using a different word. Really, I should be using the word mass, which is the proper scientific term for what we measure in grams and kilograms. As far as we really need to be aware, they are effectively the same thing. Technically, in science, they are not the same thing. Mass is the amount of stuff that is there, the amount of lead, the amount of wood, the amount of feathers, the amount of water. Weight is the action of gravity, the Earth's gravity, for example, pulling on that mass. As far as we really need to be aware, they are effectively the same thing, at least at the level that we are talking about. But there is a link between the weight and the volume of something, or the mass and the volume of something if we're being more precise. And that link that we're going to talk about, questions to do with this kind of topic, requires us to talk about mass rather than weight, because the questions will use the word mass rather than weight. They will be scientifically proper about it, so we should be as well, at least to the point of recognising this word mass, that really it's just a fancy posh word for weight, and as far as we are concerned, they're kind of the same thing. It feels like an obvious thing to say that there is a link between mass or weight and volume. The bigger something is, the more it's going to weigh. The smaller something is, the less it's going to weigh. So if we have a big volume of a heavy thing, that's obviously going to weigh much more than a small volume of a light thing. And we can kind of combine those ideas of big and small in terms of volume, and heavy and light in terms of mass, and we can sort of scale things. We could rank things in terms of how heavy they are. But there is a slightly more precise link between them. Because imagine if you went into a room and that room was filled with air. Now you could walk through that room really easily, because all rooms are filled with air, that's perfectly fine. Now imagine if you went into the same room but the room was filled with water. Assuming you could breathe under the water, you had some way of breathing, you could still move through that room. It would be harder to do, though, than with the air. You'd have to push through the water. It would take a little bit more effort. Now imagine that you went into that same room and the room was filled with lead. You would find it very, very difficult, not to mention very uncomfortable, trying to move through the room of lead. And that's nothing to do with the weight or the mass. It's nothing really to do with the volume, because the room hasn't changed in the three scenarios. What that difficulty to move through is linked to is another idea that connects the mass and the volume. And that idea is something called density. Now, density tells us how much stuff there is of something. If we think about the air, water and lead example again, the air is not very dense at all. The atoms in the air are very spread out and there isn't much stuff there. So it's very easy for us to push through it because it's not very dense, it's not very thick, it's not very solid. If we think about the water is a little bit harder to push through. The atoms, the molecules in the water are slightly closer together, there's slightly more of them. But it's still possible to push through because they're not closely linked, it's not a solid object. So we can push through a little bit more easily, but it takes a little bit more effort because it's more dense than the air. There's a little bit more stuff there. And then we move to something like lead. Now the atoms in the lead are very tightly packed. So there's a lot of them there as well. And so the lead will be very difficult to push through. It's very dense, it's very thick, it's very solid. In fact, density, you probably have a bit of a concept of density from life. If you think about a particularly mean thing to say, calling someone dense, you are effectively calling them a little bit thick. Well, that's because density is to do kind of with the thickness of an object, how much stuff there is. And something that's very dense is very thick, very solid. Something that's not very dense is not thick or solid at all. But clearly, just thinking about it on a common sense level, there's going to be some link between density, mass and volume. The bigger something is, and the heavier it is, the more stuff is going to be there. So bigger objects, heavier objects, generally speaking, will have a higher density. Light objects, smaller objects will have less density because there's less stuff there. So there is a link between the three ideas, density, mass and volume. And what questions will have us do is they will have us work with this link between density, mass and volume. We will be given two of those three pieces of information and asked to find the third, using some link between them. Now before we can do that, we need to firm up this idea of density a little bit. We need a proper definition. And so we say, the proper definition of density is that density is the amount of mass, weight, an object has for 1 unit of its volume. Now what on earth does that mean? Let's unpick it a little bit. We could try to unpick this definition by thinking a little bit about units. If we think about mass first of all, well, mass, we're talking about weight, really. So we're thinking about weight units that we could use, i.e. grams or kilograms. There are obviously more, but we're going to stick with the metric ones, grams and kilograms. Now if we think about volume units, the volume units we're talking about, we're probably going to be sticking with metric ones as well. So volume units, we're thinking things like centimetres cubed, metres cubed, that kind of thing. We could have millimetres cubed and kilometres cubed as well, I guess, but the ones we would tend to see when we're talking about density, centimetres cubed and metres cubed. Now what this definition then is telling us is that the density is the mass, the number of grams or kilograms per 1 centimetre cubed or for 1 metre cubed. The mass per each 1, for example, centimetre cubed. We can join these mass and volume units to make a unit of density, and once we do that, it should hopefully become even clearer what the density actually is. But while we're doing this, think back to another measure that was made up of two different units joined together. Think back to when we talked about speed. So remember, the speed was the distance covered in 1 unit of time. Miles per hour, the number of miles covered in 1 hour. Kilometres per hour, the number of kilometres covered in 1 hour. Keep that in the back of your mind for the moment. The two most common density units will be grams per centimetres cubed and kilograms per metres cubed. How does this link to the definition? Well, remember, the definition of density is the mass per 1 unit of volume. The amount of mass, grams or kilograms, per 1 unit of volume, 1 centimetre cubed or 1 metre cubed. Grams per centimetre cubed is in the number of grams for each 1 centimetre cubed. The number of kilograms for each 1 metre cubed. And there is this kind of callback to the speed units. Speed, the number of miles for 1 hour. The number of kilometres for 1 hour. The number of metres for 1 second. They were distance per unit of time. These are weight or mass per unit of volume. The number of grams for each 1 centimetre cubed. The number of kilograms for each 1 metre cubed. We can give these symbols as well. Grams per centimetre cubed. Grams per centimetre cubed. Or kilograms per metre cubed. With that slash meaning per, much as it did with the kilometres per hour. But the density, the amount of stuff that is there, the number of grams in 1 centimetre cubed of a particular substance, the number of kilograms in 1 metre cubed of a particular substance. And this gives us everything we need to be able to work with questions. If something has a density of, for example, 8 grams per centimetre cubed, what that means is that the object, the substance, the material, for each 1 centimetre cubed, 1 centimetre cube's worth of it, that's a cube with 1 centimetre sides, 1 centimetre cube's worth of its volume, has a mass of 8 grams. 2 centimetre cubes worth of it would have 8 grams in the first centimetre cube, 8 grams in the second centimetre cube, so that's 16 grams altogether, and so on. 8 grams per centimetre cubed, 1 centimetre cube's worth of that substance has a mass of 8 grams. However, density is a very unfamiliar thing. We have a concept of, for example, speed from life, so we can kind of have a bit of an intuitive feel for working with those questions on that particular compound measure. 2 different units joined together to give us a new measure. This is also a compound measure, but density is much less of a common thing that we might think about. We have no intuitive understanding of it, probably, besides just that heavier things are obviously a bit thicker than lighter things. So it would be useful if we could have something that was quite familiar to help us with these questions, rather than have to learn too much new stuff in one go. If we can make it so that the only new thing here is the actual density units, really, and everything else be quite familiar, that would be really helpful. And it turns out that we can. Because it turns out that we can tackle these questions that are, you are given 2 units out of 3 and asked to find the third one. Turns out that we can tackle these questions in the same way we did the speed questions. Because the speed questions were 3 units linked together, where you're given 2 and asked to find the third one. So we can tackle these questions with a variation of the method we used for the speed questions. We can set up a table, and we can have different rows in the table, and we can treat these questions much like we did then with the speed stuff. We just need to modify the table slightly to work for us here, which is simply a case of changing some words, some labels in the table. Let's have a look at a particular example to unpick this a little bit. A lump of metal has a mass of 8 kilograms and a volume of 2.5 meters cubed. Work out the density. So we know this is a density question, partly because it mentions the word density in there, but also because it mentions mass and volume. Any question that connects mass, volume and density is going to have to be one of these questions. There are 3 things that we could be given: mass, volume and density. We are given the mass and the volume, and we are asked to work out the density. So we're given 2 out of the 3. Whenever we see one of these questions and we recognise that it is a mass, volume, density linking question, we draw ourselves a table. And the table looks very much the same as the one that it did when we were doing speed. So we have 2 rows in this table, and we have 2 columns in this table, mainly. The idea being that we have the top row is the density. So when we did speed, this row contained information about the speed. Now we're doing density, this row contains information about the density. And then we have the substance itself. So when we did the speed questions, this row at the bottom contained information about the actual journey that was taking place. That was the car that was driving, the person that was walking, whatever. This is the substance, the material, the metal in this case. You can label that whatever you want. You can label it as metal. A lot of these questions will use metal as the substance, but it doesn't have to be. It could be anything. It could be wood, it could be cheese, it could be anything. So I'm going to call it substance in here, material, metal, whatever you want to call it. It really genuinely doesn't matter. But the top row is going to be the density, and the bottom row is going to be the actual thing that we're looking at. Much like we had speed on the top row and the journey on the bottom. We've then got our 2 columns that we need to fill in. Now with the speed questions, this first one was distance and this one was time, because the 2 units that were linked to speed were distance and time. Here we're going to have our 2 units in much the same way. We're going to have the mass one in the first, and we're going to have the volume one in the second. Now, there was one more thing we filled in when we talked about the speed questions, because with the speed questions we said that speed was the distance covered when the time unit was 1. The distance covered in 1 hour, or 1 minute, or 1 second. Here, the density is the mass of a substance when the volume is 1 centimetre cubed, or 1 metre cubed. The density is the mass when the volume is 1. And it turns out we can put the 1 in that top right-hand box once again, because it's exactly the same table as with speed, it's just that we've got slightly different labels in it. The density is the mass, the amount of stuff that's there, the grams or kilograms, when the volume is 1. When we are looking at 1 centimetre cubed, 1 metres cubed, or whatever. We probably want to put some units on this, so we're going to comb through the question. Well, the mass units are given to us, that's kilograms. It will either be grams or kilograms. The volume unit that's given to us, metres cubed. It will probably either be centimetres cubed or metres cubed. Density units, we don't know. We're not given those in the question, but we can work them out. If density units are a combination of the mass and the volume, it's the mass per the volume, so they will be kilograms per metres cubed. Kilograms per metres cubed. And our answer, when we work out the density, will be given in kilograms per metres cubed. We just need to work out how many kilograms per metres cubed. Once we've drawn our basic table, which will always look like this, just with slightly different units perhaps, we need to pick the information out of the question and work out where it's going to go. So a lump of metal has a mass of 8 kilograms and a volume of 2.5 metres cubed. Those numbers are talking about the metal, which means they need to go on the row for substance. The metal has a mass of 8 kilograms, so the 8 needs to go in the mass box for the substance. And a volume of 2.5 metres cubed, so the 2.5 has to go in this box here, because that's the volume of the substance. A lump of metal has a mass and a volume. We've got one box missing, and that's the mass information for the density. But that's good, we should have a box missing because that's the one that we need to find out. We need to work out what that is, because that will then, the number that goes in here, allow us to read the density as being this many kilograms per metre cubed. And that's the density, the number of kilograms in 1 metre cubed of the particular substance. Next step with this table, we turn each row into a ratio. So we're going to turn the top row into a ratio. That's an incomplete one. We're going to turn the bottom row into a ratio. That's a complete one. 8 to 2.5 on the bottom, something to 1 on the top. We start with whichever row is complete. The bottom row is complete, 8 to 2.5. We need to try to get from that particular row to the other one. So we could look at this pair here, say, the 2.5 down to 1. How do we get from 2.5 down to 1? By timesing or dividing, because we're just scaling ratios. Well, if we do 2.5 divided by 2.5, anything divided by itself will give us 1. So if we divide by 2.5 on the right-hand side, on the volume part of it, then we will get down to 1. If we do, on the left-hand side, 8 divided by 2.5, that will give us the mass information for the density, because we're scaling both sides of the ratio down by the same amount. So we grab our calculators maybe, 8 divided by 2.5, and that will give us 3.2. It is quite normal for these density values to be decimal based. They are actual real life values in a lot of cases. Density can be calculated, and it is calculated in much this way. So because densities are going to be known, and nature is never really that neat to give us nice whole number answers, most density values will probably be decimal values. All we need to do now is we need to pick the information out of the table to find out what we need to know. A lump of metal has a mass of 8 kilograms and a volume of 2.5 meters cubed. Work out the density. The number given to us, 3.2 kilograms in 1 meters cubed, so 3.2 kilograms per meters cubed. And we've worked out the density of the particular lump of metal. A lump of metal has a density of 3.5 grams per centimeter cubed. If the mass of the metal is 24.5 grams, work out the volume of the lump of metal. So once again, it's one of these density, mass, volume questions connecting the three things. We are given a density and we're given a mass. We're asked to find a volume, so we're given 2 out of the 3 and asked to find the third one. As soon as we recognise it's one of these questions, we draw ourselves a table, and it's the standard table, always the same every time. So we need a row for density and a row for the substance. It's a metal once again, whatever you want to call it. We're going to give that column the label. We also need a column for the mass and a column for the volume. And the density, remember, is the mass, the number of grams or kilograms, when the volume is 1 of that particular unit. So we can put the 1 up in that top right corner as well. Then we need to go through the question and transfer the information out of the question into the correct box in the table. A lump of metal has a density of 3.5 grams per centimetre cubed. Well, first thing, we can fill in the units there. The density units are grams per centimetre cubed. It's given to us this time. We can then rip that apart and get the mass units and the volume units. Grams per centimetre cubed, so the mass unit's going to be grams and the volume unit's going to be centimetre cubed. And the density there of 3.5 grams per centimetre cubed means that this particular metal has 3.5 grams worth of mass or weight for each 1 centimetre cubed that we're given. The 3.5 then is a density number, so he's going to have to go on that density row, i.e. he's going to go here. 3.5 grams for each 1 centimetre cubed. If the mass of the metal is 24.5 grams, so 24.5 goes in here. Work out the volume of the lump of metal. We don't have any information for the number down here, the volume of the substance, the metal, but that's good because that's what we're looking for. Next step then, once we've got all this information in the table, we turn the top row into a ratio and we turn the bottom row into a ratio. The top row is a complete ratio, 3.5 to 1. The bottom row is not. That's okay, which means we're going to start with the complete one and we're going to work our way towards the incomplete one. We're going to look at the 3.5 and the 24.5, for example. Clearly that has scaled up in some way. We've done 3.5 times a particular number to get to 24.5. We need to know how many times bigger. Well, how many times bigger is exactly how many 3.5s fit into 24.5, i.e. 24.5 divided by 3.5 will tell us how many of those fit. 24.5 divided by 3.5 is 7, it turns out, which means we have times by 7 on the left there. 3.5 times 7 gives us 24.5. If we've times by 7 on the left to keep the ratios intact, we have to times by 7 on the right. So on the right, we've got 1 centimetre cubed times by 7 is 7 centimetres cubed there. Which means overall, when we pick the information out of the question, we need to work out the volume of the lump of metal. It's exactly the number that we've just filled in. So we say that the volume of the lump of metal is 7 centimetres cubed.